Lori, could you do the spotlighting of folks as we switch back? Well,
Yes,
actually,
no
I think
problem.
spotlight.
You already just did it, whatever you did.
Yeah, I think I added me and John, so hopefully that will work.
Yeah, and then the student, I don't know if you want to add the students, but
I'll do them when they speak. All
do
right.
you want to do that or me?
You can. That'd be great.
I don't care, either way. Okay.
I'm going to be probably a little distracted. So thank you. All right. Thanks everybody for coming. And we have a nice, cozy little group of y'all today. So please feel free to turn on your videos and show us your smiling faces. That would be great. It's been a long Zoom day for many of us. We've been in meetings and class and all those things. Always much better to talk to an actual person rather than just a blank screen. So yeah, please unmute. And when you have a question, just jump on in. That's no problem. But we'll go ahead and get started. We are coming to you live from all of our living rooms and dining rooms and all those things to talk to you about agricultural and biological engineering today. Specifically our agricultural engineering majors, two of which we have students here to talk to you about the two majors and myself and Dr. Evans. So we have environmental and natural resources engineering and machine systems engineering. So we're going to go ahead and get started. Briefly introduce ourselves. My name is Sarah McMillan. I am an associate professor. I teach in our environmental and natural resources engineering program. I teach a number of classes, both at the undergraduate and graduate levels you can see here. And my major research specialization is on water quality and biogeochemistry. Biogeochemistry is a real word, by the way. It's kind of a mouthful sometimes. But mostly I think about how water quality changes in response to designs that we do that are ecological in nature. So thinking about restoration, stormwater management, creation of innovative agricultural conservation practices, things like that.
And I'm John Evans. I'm an assistant professor in ag engineering, and I teach a few ASM courses at the senior level, so power machinery management and some advanced machinery technology. I also teach capstone, which is through AE and ASM. And my research interests are around precision agriculture, machine automation, and robotics. So I'm thinking about how to use data to make things more efficient in the field.
And we have two students with us today. Megan, would you like to introduce yourself?
Yeah. Hi, my name is Megan. I'm a senior in ENRE, and I'm from Mason, Ohio. I'm an ambassador here in the ABE department. So I'm always at these FYE presentations. My favorite class in ABE so far has been Ecological Restoration Engineering, which was Dr. McMillan's class. We learned a lot about stream restoration and nutrients and soils and water and how to kind of mitigate pollution. I've also worked in Dr. McMillan's research lab since the summer after my freshman year, and I had my own research project where I studied how socioeconomic factors like race, income, and education affected the implementation and access to urban green space. So that's parks, community gardens, things like that. I had an internship after my sophomore year with the Indiana Department of Environmental Management, IDEM. It was mostly a biological internship. We were going around the state sampling fish communities because those are an indicator of environmental health. Some species are more sensitive and tolerant to pollution than others. So if you see like only one really tolerant species, then you know that the water quality isn't that good. And we also looked at other habitat indicators like stream morphology, plant communities, things like that. And after I graduate, I'm hoping to get a job. I'm hopefully close to an offer. I would like to work on stream restoration. And on campus, I am also on the cross country and track team. That's a little bit not updated, but yes, I do that too.
She's a little busy. Most of our students are. Oh, sorry. That was a double click. I didn't mean to skip you, Garrett. Please go ahead.
That's okay. My name is Garrett Ola. I'm a senior in environmental natural resources as well. I'm from Palmyra, Missouri. If anyone's familiar with the state, it's within the northeast corner of it. My favorite class was soil and water resources engineering, and that was a lot because it provides a lot of the fundamentals that go into what I have chosen my career in and that now I've accepted a job in. But and that's kind of what my experience has been around as well. I had a internship after my freshman year with the Natural Resources and Conservation Service, where I was able to develop a drainage program that you can see there. It's called SWAMP. I even got to design the logo for it, so neat. And then I served 3 terms of a co-op in Dallas, Texas with a land development civil engineering firm. And the first half of that was primarily just the creation of construction plans for commercial, residential, industrial buildings and developments. And then it kind of swung into what I now have accepted a full-time job in, which is hydrologic and hydraulic modeling. And like it says there at the bottom, I have that in Indianapolis with a company called Y Engineers. And then on campus, I'm the vice president of ASABE, the American Society of Agricultural and Biological Engineers. I was a 2-year member for the Purdue Agricultural Council, and in my free time, I enjoy running and canoeing.
Thanks, guys. So we're going to kick it off here with a little storytelling. When we talk about agriculture, many of you probably think of the kind of agriculture that we see around here, around West Lafayette and Indiana, the pictures that Garrett showed of him doing some surveying and looking at drainage pipes. But agriculture means a lot of different things. And a lot of the things that we do in some of our disciplines are really supporting a really diverse food system, but also kind of somewhat disconnected from food in general. But this is a great example of how the several different groups of our department kind of connect together. And so you can see, obviously, this is a strawberry farm, and there's growing happening at really high technical levels. You can see irrigation piping, you can see a hoop house, which is basically that kind of greenhouse that's shaped like a half moon shape, raised beds, all kinds of really high technical sensors in place here to make sure that soil moisture is just right, to make sure that air temperatures are just right. So a lot of what we do in agriculture engineering is integrate this high tech kind of Internet of Things that kind of has started with all of the cell phones and all of the things that are now in our refrigerators or whatever it is that, you know, next thing that's connected to to the Wi-Fi world that we live in. But really trying to use that technology to help us make better and smarter decisions, both for, you know, growing food, but also for keeping environments safe and healthy, for thinking about how we might bring strawberries that are grown in California, logistics of getting them safely to our tables here in Indiana. So there's a lot of things that our partners, it's very interdisciplinary. There's a lot of breadth and depth to our program that you may not have thought about. And we're hoping that today, when talking about some of this, you'll get a sense of that breadth and depth and the things that you might find yourselves able to do if you were to join our program. So we have 3 majors in our school. We have biological engineering, which we came and talked to the group about 2 weeks ago. And we have 2 other majors, agricultural engineering and environmental and natural resources engineering. 2 students here are from ENRE, but we teach in ag engineering, so Dr. Evans especially can answer a lot of questions if you have them in that space. So we're going to talk about those last 2 majors today. And to start it off with, though, I'd like to introduce you to our faculty. These are the faculty that primarily teach in our environmental and natural resources engineering program, some at the graduate level, some at the undergraduate level, and a lot of us blend and cross over into different kinds of disciplines. So for example, Dr. Saraswat teaches a lot of GIS courses, how we think about GIS, which is basically Google Maps, but amplified and, you know, made into a really useful tool for us to make decisions with, using satellite imagery from that, as well as imagery from drones, so that you can imagine has lots of potential for agronomic impacts, but also environmental ones. A number of our faculty teach, there's a little bit of their expertise underneath of their names. And many of these folks do research with undergraduates, as Megan mentioned. I have a lot of undergraduates in my lab. I'm a field scientist, so I do a fair bit of lab and field work, and that's always a great opportunity for students to get engaged with. And I'll let Dr. Evans introduce most of these folks.
Yeah, so these are some of our faculty on the ag engineering side. And these are a mix of ones who, similar to the other side, teach both graduate and undergraduate. So if you choose our major, you're going to see a lot of Dr. Stwally, who teaches quite a few courses in the department. You'll see myself and Dr. Lumkus towards the end. We teach capstone along with Margaret Gatow, who's in REA. We actually do that all together. So a great group of people here, both in terms of the research and the teaching.
Mhm. And I think our students can offer a little bit more about our faculty, but one of the nice things about it is that we are all pretty well engaged with our students. I think most of us, especially with our access to being, slowly coming back together, it's hard with COVID, but we are very excited about having, a small program that we get to know all of our students pretty well. So I'm going to start us off with a video that hopefully will play. I'm not hearing any noise. I'm not sure what happened there. Let me try that again, guys. It's a pretty cool video, but it's not wanting to play. So I'm gonna stop sharing for just a second. I'm gonna try it one more time. And it appears to be not working. So skip that. Best laid plans, that's the way it goes. Sometimes those things happen, technology. No problem. So let's just jump right in and talk a little bit about our program and some of the things that we do in how we integrate our different parts of our major together. Big thing that our students come to ag engineering for is they have a lot of them have an interest in thinking about grand challenges that are affecting our society, whether that be sustainable food production or things that are not really related to farming at all. Things like, how do we keep clean water for ecosystems and people? How do we provide clean and renewable energy? So while agriculture is in our title, it is not in everything that we do. And you do not need to be from a farming community or from a farming background to be successful and to have a really great experience in our department. One thing that we're really excited about, and this is a tweet from me a few months back now, last fall, when we first got these rankings sent out, we are the #1 ranked undergraduate program and have been for some time. We're also the #1 ranked graduate program and have been for some time. So it's a pretty exciting place to be. The graduate program, the reason I bring that up is because a lot of our undergrads do research with our amazing graduate students. And this is a really nice way in which you can get mentored not only by a faculty member, but by a more senior graduate student who can kind of show you what it might be like to do applied work, whether it be research or otherwise, in our program. Dr. Evans, you want to jump in?
Sure. So we have a pretty unique experience, student experience in ABE. So one of those things is we're both in the College of Engineering and in the College of Agriculture. So that opens up a lot of opportunities in terms of travel for scholarships. #1, you get scholarships. You're able to do them in either college. There's also a lot of opportunities for things like travel abroad or study abroad, which will hopefully be back soon. We have really small class sizes with hands-on labs. So every class we teach has a lab associated with it. So you kind of get to mix the theoretical and the physical, which is really unique. As I mentioned, we have a small student to faculty ratio, so 12:1, which is, I'm sure, one of the lowest across the colleges of engineering. And then again, because we are in the College of Engineering and Agriculture, all those extra opportunities for internships, competitions, which I'll talk about later, research, both at the undergrad and graduate level, which we'll touch on going forward. And like I mentioned, the study abroad experiences. We also just moved into our new building. So this was a shot from a couple months ago, but all that stuff's cleared out. We are open and doing business. Really excited. So this started out as one story with that 3-story part you see in the back, and it was totally, the 1-story part was demolished down actually below the surface. Basement was made. The 3-story part was gutted, and now we have a new 5-story research building with our newly renovated 3-story office building. So great space to work. I've been enjoying the classes this semester in the research labs. In addition to that, we wanted to mention the scholarships available for ABE students. So annually, we award about $145,000 worth, and 24,000 of that went to sophomores who chose AB as their major. So if you were to pick your major and come in next year, you would be eligible for some of that scholarship.
That I don't know, depending on your perspective, might seem like a lot or a little, but with a small department, that is a fair bit of money. And our students, I would say, I know these two on the call down have been recipients of some of those funds, and so it's really it's a really great thing that we're very happy to be able to offer to our students. There's a lot of stuff, so please don't read all of the words. We can come back to this if there's interest. But what we try to do with this slide is kind of highlight the fact that we have a lot of courses that are common to both of these two majors. And basically what you'll see if you do start reading into these words is that this is a lot of what every engineering major takes. Things like your chemistry, physics, biology, although the biology is over here more so than maybe in ag engineering, but there's a lot of math, just like most majors, right? And then we have some common classes, such as computations course on biological materials properties rather than physical structural materials, like maybe steel or something like that. But we actually talk about biology and how those biological materials react. We have a course on electronics with both of our students take that allows them to really understand how do sensors work and how can we use advanced kind of tools to help us get data or think about controlling processes. And both of our groups, both majors take a soil science class. And as Dr. Evans mentioned, we do have a combined senior capstone with generally the two different majors kind of separating out, but sometimes they get to work together depending on the type of project and the interest of the students specifically. So, and you can kind of see the different courses that are listed here in our machine systems major. There's a lot of courses in design, both from, kind of machine component side, but also some technical modeling side. And I want to just point out that all of these courses that are ABE courses have hands-on labs associated with them, both in ag engineering and in our environmental program. This is really, really important because we know that most students, I wouldn't say everyone, that's hard to generalize, but it's pretty much well established that the more learning you can do that's applying your knowledge to solving a new problem, open-ended problems, things like that are really kind of hands-on tinkering with stuff, the better you do in your future careers where you're applying this knowledge to new things, but also just kind of retaining that knowledge in a way that's meaningful to you. So every class that we have has a lab, whether it's a computational type lab or a hands-on kind of building and tinkering kind of lab. Anything else to add, Dr. Evans, that I missed here?
I think you covered it well.
Okay, we'll move on. And I'd like to just call on the students. Sorry, guys, I didn't give you any super heads up, but you've done this a few times, so hopefully this will be pretty straightforward. I'm going to talk a little bit about what it's like to be a student in our department. This is a picture from last year of our ABE ambassadors when we actually, as you can see, nobody has masks on. This was prior to COVID, so everybody's actually in one of our building, in our rooms when we were kind of housed temporarily in Lilly Hall. Okay, so global opportunities, I think Dr. Evans is going to talk about this and then we'll pivot off to the students. Okay, sorry about that.
Yeah, so the one I'll talk to is the Pursuit Utility Platform, so PUP team, as it's known around here. And this is a great chance to get involved from the start in our department. So this is a student club that you can join, and basically they work on building utility vehicles for underserved or developing countries. So specifically in Africa, and they've gone to a couple of different countries, and they elude me off the top of my head right now, but and actually built these. So they designed them here using cheap parts that you can find around that would be available in those developing worlds. And so you can see they're repurposing a lot of car parts and things like that to keep them affordable for these lower income nations. And then they go over there actually in the spring and build these. And so it's a great outreach program and a great chance to study abroad.
So in addition, so if you're not interested in kind of tinkering with those kinds of vehicles, there are lots of other ways for students to get involved in global opportunities. One of which is senior design. I would say about half of the time we have I'm sorry, all of the time, about half of the projects are global in some aspect. We have a lot of really great partners across Latin America and in Africa, South America as well. So there's a lot of opportunities for you to get engaged with that if that's something that you're passionate about. We also have research opportunities. Many of us do international research. The picture on the left is a picture of me with some of my partners working in Peru. And Megan is actually helping with this right now because we've been doing a lot of work on soil and water health. How do we get, Peru often we think of as, you know, the Amazon and very lush rainforest tropical environment, but much of Peru is incredibly, extremely dry, the driest place, hottest place on earth, it seems sometimes. And so how do we farm this land and how do we create sustainable kind of living conditions for folks? And so one of the things we're working on there is how do we do better water management. And so we've been doing a lot of work with local students, with different groups like that. And Megan's helping us really take a lot of our research and turn it into things like extension documents and kind of videos and things for the local communities to use and apply the work that we're doing. Garrett, do you want to talk about the student club since you've kind of been engaged in a lot of this stuff?
Sure, yeah. I mean, kind of with all engineering departments, there's tons of clubs, and that certainly is abundantly the case in ABE. And those are the kind of things where you can get early leadership in, and then kind of like with the global opportunities, there's also a lot of like contests that you can get involved with that pay out, you know, actual money. And so it's like, there are a lot of things offered, professional societies, as well as, you know, things that are focused on informing, you know, students. I've been in AB ambassadors for 3 years now, and a lot of that focuses on outreach to FYE students as well as, you know, interacting with middle schoolers and elementary schoolers and high schoolers. So there's a lot of really cool things, and then really good things to boost your resume so that you can kind of get your foot in the door for, you know, eventually getting that lab position or getting the job or the internship or co-op. So, you know, because this is a smaller department as well, there's more of those opportunities out there. And with more opportunities, there comes those more opportunities for leadership as well. So, you know, just kind of speaking to the point that within ABE, there's a lot of, you know, programs and clubs to join that really kind of help you move along to getting into your career.
Megan, do you want to jump in here?
Yeah. Oh, I'm on that slide now. Okay.
You're famous.
So I've been involved in undergraduate research in Dr. McMillan's lab for 3 years. I started out just kind of learning the ropes, helping grad students with their projects, which was really cool because I wasn't sure exactly what I wanted coming in, which is fine. Like, you can join a lab and then decide that you want to do something else. And it's just a great way to get experience doing science work and know what you might want to do after college. Do you want to go to grad school? Do you want to get a job? Is this the right field for you? Things like that. So I highly recommend it, even if you're not sure you want to do research forever. But I started out learning about nutrients and floodplains. I was working on a project that was assessing the loads of nutrients in soils and water from different floodplains around the Wabash River, without getting too much into it. And then I started my own project, which I talked a little bit about before. And I really got to get more hands-on experience using different software with that. I learned GIS really well, which is like a mapping software where you can look at different data spatially distributed. Like, mine was all around the state of Indiana, so you can see the income in this specific census tract, things like that, and along with the locations of parks. And I think GIS is a really important tool if you're going into ag engineering. So having that extra experience with it really helped me. And now I'm working on the Peru project, and I'm bettering my communication skills through that, learning how to put this scientific language that I can understand and that other people in ABE can understand, but that lay people can't understand, and just learning how to breach those barriers and get the information out to the public.
I think you're probably one of the most diverse research experience folks we've got right now. It's a lot of different things.
Yeah, I think I'm a great example of somebody who like wasn't quite sure exactly what I was going to do.
That's awesome. Go ahead, Dr. Evans, do you want to jump in here since
Yep.
this one of these is your, actually two of them are your clubs you advise.
Yeah, so we also have a great opportunity for undergraduate interaction with competition. So we have soybean innovation competition, which I'll admit I don't know a lot about. I know there's a large cash prize associated with that, so that's always a bonus. But my understanding is they're basically looking at new ways to use soy to create products or new products to put it in. And then we have the Agrobot Challenge, which is relatively new within the last 5 or 10 years, I guess 5 years. And it's recently been taken over by Purdue. But essentially, the team goes and builds a robotic implement for weeding. So the last few years, it's been a what's called a weed and feed challenge. So you can see that kind of hood on top and in front of the UTV. It's actually creating a place for where they can do artificial light and point cameras down to identify weeds. And then as they drive through, in the back, they either can eradicate that weed using a chemical means, so spraying it, or eradicating it mechanically. So really neat robotics challenge. And then we have our quarter scale tractor design team. So this is what I'm heavily involved in, have been for the last 10 years. And this is a really great competition for students who are enjoy getting their hands on mechanical things and learning to design and build. So every year we go through the design and build process for one of these quarter scale pulling tractors. Students learn how to take what they've been learning in class and actually design and get the experience of taking that design and bringing it to life. And so we go up in a normal year, compete against 20 to 30 other teams from across the United States, Canada, and Europe. They bring their tractors over. We all compete. There's a oral and written part of it, and it's judged by industry professionals. So a great networking opportunity and just learning.
So to wrap it all up, we want to just give you a sense of some of the jobs that our graduates go on to take. You got a good sense, I think, from both Megan and Garrett of what they're looking at. And I would say increasingly, our ENRE students are more and more going to environmental consulting firms. These are firms that are doing things like flood mapping, like land development, like restoration design, like stormwater management, stuff like that. An example role might be a restoration design engineer. Many of our students who go this route, we encourage them to take the FE, which is the Fundamentals of Engineering exam. I think both of you guys have taken that, yeah? And basically what that lets you do is after a few years of working as in a firm like that, you are able to sit for your professional engineering license. And that lets you do things like stamp plans and be responsible, which is great. Also gives you a promotion usually. Many of our folks do go still to other kinds of roles. I would say a large number do go to governmental agencies, either as interns or as their final job, as well as non-governmental organizations. So things like you might want to go work as a conservation engineer for the Nature Conservancy, for example. We are increasingly having folks be really interested in like tech design startup companies, things like that. I was talking with one of our graduates today, who's now in our graduate program, who works for a company that's kind of designing new ways in which we can think about smart seed design and how do you do better hybridization and pollination of corn crops. It's pretty fascinating kind of intersection of biology, technology, data, engineering, pretty cool kind of startup company that he's working with. And there also is a potential for you to enter into environmental kind of policy and law practice. It's a great jump off if that's something of interest to you. And I just kind of have a little smattering of different places where our current graduates are working. You can see there's a few governmental agencies here, but also a lot of those land development style environmental consulting companies.
Yeah, so on the ag engineering machine systems side, your likely employers are going to be some of the obvious ones like agricultural manufacturers. So those are going to be the John Deere's, Kubotas, basically the big tractor companies. But in addition to that, that's not the only place you can go. So another group that we send a lot of students to is the off-highway and large equipment market. So that's going to be companies like Caterpillar, Datsun, some of those that are making big construction equipment, and John Deere construction, as well as food production equipment. So some things you wouldn't necessarily think about, but our graduates find employment in, as well as just engineering, design, and consulting firms. So these would be firms that would hire out to solve specific problems for companies. And then also in international agriculture. So just to kind of give you a little breadth, you're not, if you get a machine systems degree, you're not necessarily pigeonholed into designing tractors. There's a lot of places our people can go. And not on that list too is just big car manufacturers. So we send a lot to Toyota, Ford, Subaru, all the places you expect.
Okay, sorry, one more backwards. So that concludes our presentation. I did want to kind of leave this up here for just a second because there's a lot of information out there on our website. You can go find us at engineering.purdue.edu/ABE. There's things like courses and, kind of different kinds of opportunities, connections with alumni. How does everything all fit together? And then, but this is not your QR code to get credit for the class. In fact, this is a different QR code, but if you scan this, it'll take you to a Qualtrics survey that's really connecting with us. It gives us an opportunity to invite you to come and take a tour of our amazing new building. We're pretty excited about that. We actually have our AP ambassadors are still kind of hanging out and giving tours over the next, I think, one more week, you guys, is that right? Or are we all done? I think we're pretty close.
I know that I'll be there Thursday, and then I think we have one more week after that, and then we're done.
Okay, we can talk a little bit about that if folks have questions. But yeah, scan it and let us know what your interests might be, and it gets you connected with Dan Taylor, our resident recruiting guru, who really is a great resource to help answer any more questions you might have about how you might fit in here in our department. So with that, I will stop sharing and ask that once again, even though I asked once and we did not get a good response of turning off on videos, ask you to do so and let us know what questions you might have. And that way we can, help you figure it out. I think we will, everyone is very, very bashful this evening, apparently. No questions and no videos are being shown.
Crickets.
Crickets, crickets, crickets. You can, delete that part out of the video, hopefully. Do any of you have any questions? Place them in the chat if you don't feel like you can, and please just unmute yourself if you have questions. It's much better than trying to type anyway. Okay.
I have a question for the students. Students, what made you interested in agricultural engineering or natural and environmental resource engineering? Just anybody share what made you want to listen to this presentation, besides the fact that you have to for EY or FYE requirements. Is there something else of interest to you all?
I just sort of did it to learn about another field. I'm really thinking about civil right now, but I hadn't heard about agriculture, so I thought I'd give it a listen.
I say you have a kindred spirit in the room. I might put Garrett on the spot because he and I had several conversations about what the best fit for him was, and then he actually had better conversations, I think, with some of our alumni to help him kind of figure it out. So Garrett, do you want to maybe kind of give a little bit of your thought process between the two majors, like kind of where you landed and why?
Sure. I think that, kind of baseline, and I think that this is like good for anybody to hear that they're researching their major. But I mean, there are several, you can reach the end goal through a lot of different ways. And it's just deciding how you want to fill up that time in between. is what really, sets you aside as a candidate, right? For the ultimate career that you do. So, civil and ABE, I think that I would have had similar level of involvement, but what it really came down to is I thought, there was a lot more within ABE, club wise, and that there were relevant classes, and that really there was enough flexibility that I was able to take a lot of civil engineering courses these past couple of years that, whereas, perhaps other tracks are a little bit more strict on, hey, this is kind of the sequence. And of course I came into ABE, so it definitely would have put me a little bit behind schedule. But, the internships that I had were primarily advertised to civil engineering students. And I think that certainly that there's a very large blend between the skills that people take from civil engineering versus ENRE. But just that, it's good that you're doing these kind of things, like going and seeing what other information is out there, because what we advertise in ABE isn't necessarily going to be the exact same things that are advertised in other engineering disciplines. So just going out there and seeking that kind of knowledge, and then saying, what is important to me? Is it important to me to have exactly this, and this, and to, graduate within this time frame, or, and those are things that, I couldn't answer for you. You're not the same as me, and I'm not the same as you, but you're doing the appropriate steps, and just letting you know that, for ABE, it was a great fit for me, and it worked with my schedule, and I got a lot of opportunities with it, with leadership. I did undergraduate research. So there's a ton of things that, you can do within ABE, but you're doing all the right things.
I would say one of the things that can benefit our students is the connections of our alumni to our students. Every time I ask an alumni if they have time to have a coffee or get on the phone or even come meet before COVID, it was very rare that I had somebody say, I'm sorry, I just don't really have time, or I'm sorry, that's really just not going to work for me. I know both Garrett and Megan have talked to our alumni as well as friends of ABE as they're trying to figure out their path. And I think that's a really, that's a thing that we can do because we have a close, network of our alumni who stay connected to our department, and our faculty who know our students really well. So we get to know them in the way that they kind of help figure out what their goals are. The other thing that's cool is we work with folks like Garrett who take a co-op and they're like missing for a whole semester. And how do we make that work so that they don't fall behind? And many departments do a good job of that too. I'm not saying that we're the only one, but that is something that our advisors are really keen on, helping students find what they can do to make their experience here at Purdue the best it can be. I kind of jokingly said our students are really involved in lots of things. Megan and Garrett are not exceptions to that rule. They're very busy people, but that's kind of common in ABE for lots of our students to be engaged in lots of different things and have those experiences that kind of make Purdue, their time here at Purdue, while short, a little richer. So, and I noticed I had a little short chat exchange with Caleb. Sounds like you've already made up your mind and you're on your way, which is fantastic. And you've already been in the building. Just kind of reiterate Megan's story. She came and talked to me after one of these EYMs in the spring. I think you worked for me that very next summer. So, or fall, I can't remember. I feel like you've been around forever. Gonna be so sad to see you go. But yeah, so go check it out. Go talk to Dr. Evans. He's got some really cool toys in his lab. Not only the clubs are great, but he has a really cool robot that drives around the floor and kind of can navigate its way around desks and stuff. It's pretty awesome.
Yeah, we actually have 3 of them now. They're getting bigger.
Yeah. And they're getting bigger?
Yeah.
Cool. So we got a sense from Chris and Caleb, Tyler, Steve, or Darren, what disciplines or what majors drew you to come today?
Stumped them.
I can wait. No.
I'll answer.
Yeah, thanks, Tyler. Go for it.
All right, so I decided to come to this one because I went to the biological one last time, and I just wanted to see if this was similar or different.
So are you interested in what parts of biological engineering are you interested in?
Well, as of right now, I'm more leaning toward the chemical engineering side, and I thought biological was similar, so I thought I'd look into it.
Yeah. Yeah, I feel like there are some really great, I'm not going to reiterate the questions that were said there. I hope you kind of got a sense from some of our questions that were asked. Dr. Engelberth did a really nice job of explaining the differences between chemical engineering and biological engineering and the similarities. And I think hopefully that helped you make your decision. Yeah. Steve or Darren, do you have any thing you're willing to share with the group, or are we all done for the night? Our goal really is here to help you. I mean, I'm not trying to here to pull your teeth and make it uncomfortable. I just want to be helpful. So.
Yeah, I'm just here to explore like other majors, and like I know that ABE is like #1 for like 10 years, so I was kind of interested to see like what made ABE like that good at Purdue.
Well, I would say it's our people. We have really, really fantastic faculty and staff, and our students are top notch. But yeah, we're doing some pretty, there's some pretty amazing faculty doing some incredibly innovative research here that doesn't hurt. And then that research and those applied things get brought into the classroom. I often bring a lot of my stories from my days in consulting, as well as my research projects, into the classroom. We do data analysis in one of my classes, and a couple of those data sets are from research projects that I've been involved in. You know, we take what we do as our own professional expertise, and we don't just save that for our PhD students. We bring that all the way into our sophomore courses. John, do you have anything to add? I've talked a lot.
No, I would just echo that. I think it is really the people. And I do the same thing. I actually taught a class today that was all from data sets I collected last year. So still pretty relevant stuff. And I think the students benefit from seeing that new cutting edge stuff, and definitely contributes to our success.
Cool. Well, I think unless there's any more questions, I have dinner waiting in my kitchen right behind me. So I'm gonna wrap up this show and ask that if you are interested in kind of connecting with us, coming and seeing our building, you know, having a little bit more in-depth conversation about some of the nuanced differences, like, you know, if you're thinking about, you know, just to pick on Chris for a second, between civil and ENRE, or between, you know, biological or chemical, part of those pathways are, you know, it is variable. You can certainly get to one endpoint through many different ways. But I think that there are certainly strengths and weaknesses of different programs, depending on what you want, right? What you find most important, and what you kind of like find, where you find your passion in terms of the things you really want to study and the things you really want to work on, and how that all fits together with what your interests are. So happy to talk through some of what the curriculum looks like, or some of our other things, if that would be helpful. Just reach out to us through that QR code. I'll put that back up for just a quick second. Yeah, let us know if through here, and we can connect with you if you have any more questions. I'll look that up for just a second while you, and then you go ahead and do the QR code for attendance.
Okay, so I'll go ahead and share the attendance QR code. Okay, so if everyone scanned it, I can take it down. If you're having issues, please enter your Purdue email address in the chat. I'll give it 30 more seconds and I'll take it down. Okay.
Great. Well, thank you so much, everyone, for attending tonight. Wish you all the best in the rest of your semester.
Yep.
Find us if you need anything. Otherwise, we'll see you next year.